Something is unfolding in our solar system that no scientist was truly prepared for. On July 1st, astronomers detected a fast-moving interstellar object, now known as 3I Atlas, racing through space at an astonishing speed of over 210,000 kilometers per hour. But speed alone isn't what's turning the scientific community upside down. This object behaves in ways that violate nearly every expectation astronomers have for comets. First, its glow doesn't match the usual profile. Instead of light scattering off a dusty halo, the glow seems to originate directly from its surface, anomalous, as if 3I Atlas is emitting its own light source. Then, without warning, the object shifted color from red to green, accompanied by violent fluctuations in brightness events that occurred far too rapidly and erratically to be explained by standard comet models. What's driving this bizarre display? Could it be a new kind of cosmic phenomenon? Or are we facing something far more complex, perhaps not natural at all? These are not fringe questions anymore. The scientific community has been forced to reconsider its assumptions as 3I Atlas continues to defy all known comet behavior. The object's coma. The cloudy envelope surrounding the core is unusually thin and irregular, in stark contrast to typical comets that display symmetrical, dense halos of gas and dust. Even its tail doesn't behave normally. Rather than a narrow solar-driven stream, it resembles a diffuse, fluttering banner, a strange cosmic signature. And that's just the beginning, where normal comets brighten predictably as they approach the sun, due to ice sublimating into gas. Shows brightness spikes that occur with no apparent pattern, intensifying, then plummeting sometimes within hours, combined with the sudden color shift into green, a phenomenon rarely observed in cosmic bodies. This erratic behavior has triggered a scramble among astronomers to make sense of what we're seeing. The traditional explanation for green flashes in comets points to diatomic carbon fluorescing under sunlight. But here's the catch. Atlas shows almost no traces of carbon at all. Instead, instruments like the James Webb Space Telescope have picked up elevated levels of carbon dioxide, nickel, and even cyanogen, none of which are known to cause the green glow we're seeing. So what is the source? Is it an unknown gas or something else? Could we be witnessing the first signs of a technology we can't yet recognize? As outlandish as that sounds, it's not just internet speculation. Renowned Harvard astrophysicist Avi Loeb has gone on record, suggesting that some of 3I Atlas's characteristics might fit the profile of a controlled object, perhaps even an interstellar probe or mothership. He points to the way the object's light emission seems self-generated and how its trajectory appears unusually precise, brushing suspiciously close to Venus, Mars, and Jupiter. According to Loeb, the probability of such a near-perfect planetary alignment occurring by random chance is less than 0.005%. And this begs a larger question. Are we observing a rare natural object, or are we being watched? That question has now become central to the growing scientific and public fascination with this mysterious object. The Mars flyby on October 3rd, when 3I Atlas passed just 30 million kilometers from the red planet, offered a potential turning point. But what happened next only deepened the mystery. As 3I Atlas swept past Mars on October 3rd, multiple space agencies, including NASA and the European Space Agency ESA, activated their instruments to capture as much data as possible. High-resolution imaging from the HiRISE camera aboard the Mars Reconnaissance Orbiter was aimed directly at the object, hoping to dissect its brightness behavior, separating the core's glow from the surrounding dust emissions. This was a rare opportunity. Never before had an interstellar object passed so close to another planet while being under direct observation. And yet the data collected raised more questions than it answered. Instead of a smooth light curve, 3I Atlas continued exhibiting unpredictable surges of brightness, similar to the phenomenon astronomers call an outburst. Normally, these outbursts happen when volatile materials, like frozen gases, suddenly vaporize, ejecting dust and gas, temporarily increasing brightness. But in this case, the frequency and intensity of the flashes didn't match any known cometary model. Some spikes lasted hours, others vanished in minutes. The chemical composition also refused to fit expectations. The JWST confirmed abundant carbon dioxide traces of cyanogen and heavy metals like nickel. But the typical building blocks of a comet, water ice, and diatomic carbon were suspiciously scarce. That poses a fundamental problem for conventional science. If this object isn't composed like a normal comet, why does it exhibit some, but not all of their behaviors? Meanwhile, Loeb and his team reignited the controversial idea that 3I Atlas could be emitting energy through non-natural means. The possibility of a controlled energy source, possibly nuclear in nature, isn't being embraced by mainstream scientists, but it's also no longer being dismissed outright. In particular, the color shift from red to green caught attention. In astrophysical terms, such a dramatic chromatic transition could imply changing temperatures as gas composition or unknown excitation mechanisms. But in an interstellar object of unknown origin, the cause is far less clear. To compound the mystery, the trajectory of 3I Atlas was found to be almost perfectly aligned with the ecliptic, the flat plane in which most planets orbit the Sun. Its steep inclination, retrograde motion, and close planetary flybys raised eyebrows. While most comets are tugged by gravity into irregular paths, this object appears to have carved its own route with an eerie sense of intent. Is it just coincidence, or does the path serve a purpose? Perhaps surveillance analysis, or even data collection? Critics argue that such speculations are unscientific, driven by science fiction rather than facts. But supporters like Loeb maintain that scientific progress demands bold hypotheses, especially when the data continues to defy expectation. So far, no conclusive evidence supports the extraterrestrial theory, but no evidence rules it out either. That is the discomfort zone in which current research now operates. The object continues toward the inner solar system, set to vanish temporarily behind the Sun in late October, a period when Earth-based telescopes will go blind due to solar conjunction. And that timing has led some to ask, is this just natural obscurity or deliberate timing? As 3I Atlas disappears behind the Sun, scientists face a chilling reality. We've lost visual contact with one of the most enigmatic objects ever observed at the precise moment when its behavior could become most volatile. This blackout caused by solar conjunction means that Earth-based telescopes are blinded by the Sun's glare and unable to track the object's trajectory or any potential changes in activity. And while that may be an ordinary cosmic event, the timing feels anything but ordinary. With brightness surges chemical anomalies and a puzzling flight path already on the table. The idea that 3I Atlas could now alter course or activity completely unseen adds an eerie layer of uncertainty. What might it be doing behind the Sun? Will it erupt, fragment, change trajectory, or even disappear entirely? Historically, we've seen comets like Shoemaker-Levy 9 shatter under internal pressure and crash spectacularly into planets. Could 3I Atlas be on the brink of a similar rupture? Some experts believe its internal structure may be unstable, and that the repeated outbursts of gas and dust, if intense enough, could lead to structural collapse. But others push an entirely different line of reasoning. According to Loeb's theory, if 3I Atlas is more than a natural object, say a kind of interstellar research vessel, then its maneuver around the Sun could serve as a tactical blind spot, allowing it to adjust course or deploy instruments beyond human detection. Adding fuel to this theory is the striking proximity of C2TF2 Swan, a comet discovered just months after 3I Atlas. Although later data confirmed it emerged from the opposite direction, some researchers initially speculated it could have been a fragment or probe released near Mars. This suggestion echoed ideas around Oumuamua, the first interstellar object discovered in 2017, which also sparked debates about artificial origin due to its shape acceleration and lack of a visible tail. But unlike Oumuamua, 3I Atlas is brighter, larger, and far more erratic. That makes it harder to dismiss. Its estimated size is up to 50 kilometers larger than many asteroids, and its proximity to multiple planets, including Mars, Venus, and Jupiter, suggests that if it were controlled, it may be gathering data about gravitational fields, atmospheric composition, or even electromagnetic signatures. And this brings us back to the green flash, if not caused by known molecules. What's driving it? Some physicists propose that plasma emissions, or magnetically excited gases, could be responsible phenomena that are rarely studied in cometary contexts, but are common in high-energy systems, like stars or spacecraft ion engines. Still, skeptics warn against reading too much into anomalies. Brightness fluctuations, after all, can happen in fragile objects under solar heating. But that caution hasn't silenced speculation, and it doesn't explain why 3I Atlas's trajectory actively avoids Earth despite its near misses with other planets. According to orbital simulations, the object's path veers around our planet with almost surgical precision, another data point that fuels suspicion. Is it steering clear deliberately? Or are we merely a cosmic coincidence on a predetermined route? Loeb, while cautious, argues that the scientific community must treat unlikely possibilities with the same rigor as conventional ones. He urges that we don't dismiss the extraterrestrial hypothesis simply because it feels too strange. History, after all, is filled with discoveries that were first mocked, then proven. What if this is another as 3I Atlas continues its silent drift beyond the Sun? Scientists and theorists alike are left in a state of suspended curiosity. We now stand in the most critical observational gap, precisely when the object is exposed to the Sun's extreme electromagnetic fields, conditions under which its behavior could either stabilize, erupt, or transform in ways no one can predict. NASA and ESA are preparing for renewed tracking as soon as the object re-emerges from behind the solar disk. High-powered instruments like JUICE, aimed at Jupiter's system, and NASA's Psyche mission, originally intended for asteroid study, might contribute auxiliary data, indirect glimpses, radiation signatures, or gravitational anomalies that could hint at what's occurring while human eyes remain blind. But the window is narrow. Once 3I Atlas passes its perihelion, its closest approach to the Sun, it may either slingshot outward into deep space, vanishing forever, or leave behind data trails, fragments, or chemical residues that force us to rethink how we define natural cosmic objects. And that perhaps is the most urgent takeaway. Whether 3I Atlas is a rare interstellar rock or an engineered visitor, Its behavior has already challenged our understanding of orbital mechanics, cometary chemistry, and observational limits. It has proven that even in a highly monitored solar system, something can still sneak in, evade full scrutiny, and depart, leaving only more questions. Loeb's call for scientific humility now rings outer than ever. In a universe of trillions of stars, is it truly irrational to consider that one object, just one, might not be a random rock? And if 3I Atlas isn't the first, what if it's simply the first we noticed? With its green flashes, mysterious brightness surges, and near-perfect planetary choreography, this object might not only expand the boundaries of astronomy, it might redefine the conversation entirely. So when it reappears, will we be ready to see it for what it truly is? Or will we once again explain away the unexplainable?